So we're going to look at what's called an arithmetic sequence today. Yesterday we looked at the basics of sequences and series, and today we're going to dive into specifically what is an arithmetic sequence. An arithmetic sequence, let's fill in the blanks. An arithmetic sequence is built by starting with one term and increasing or decreasing it by adding or subtracting a given amount. So let's highlight that. So we're increasing or decreasing by adding or subtracting a given amount. So this common difference, so that's what we're going to call it. When we add or subtract by a given amount, this common difference is stated or can be found. So the difference between one term to the next is what I'm talking about. So if we look at this first term, I want you to notice 2 and then 6 and then 10 and then 14 and then 18. And notice it's going up by 4 each time. So that common difference, plus 4, plus 4, plus 4, and plus 4, the common difference is 4. So to get the next term would be just to add 4, 22, and then 26, and then 30. So the same thing with the next one. The next one is 6 and then 1 and then negative 4. So this one's going down, and it looks like it's going down by 5 each time. So the common difference in this example would be negative 5. So to get the next term, we'll just subtract 5. So it'd be negative 19, and then negative 24, and then negative 29. Okay. So the terms between the beginning and the ending terms are called the arithmetic means. That's what they're called. So if I give you the first and the last term, then to get the arithmetic mean, then you just subtract the larger minus the smaller, and then divide by how many numbers are in the sequence. How many numbers are the difference between the two numbers. So 10 minus 2, since there are two numbers in between 2 and 10. From 2 to 10, it's two numbers is what I meant. So it'd be 8 over 2, which is 4. So the common difference is 4. So to get from one to the next, I have to go up 4. So 2 and then 6 and then 10. So this example has 1, 2, 3, 4, 5. 5. So to get from one to the next, I have to go up 4. So that's what I'm going to divide by. So I'm going to do negative 14 minus 6 over 4, which is negative 5. So that's what tells me my common difference is negative 5. So I'm going to go down 5, down 5, down 5, like that. Okay. All right, so a finite sequence has a countable number of terms. A finite sequence has a countable number of terms. The first term is symbolized with a sub 1. So we're going to look at a formula for an arithmetic sequence, and we're going to call the first term in the sequence a sub 1. And we're going to call the last term in the sequence the one a sub n, the nth term. An infinite sequence goes on without end. It goes on forever. So this would be an example of an infinite sequence because you see the dot, dot, dot at the end. It's going up by 4, goes on forever. Okay, so sometimes we have a finite sequence. That's what we're mostly going to be looking at. And then we have an infinite sequence. Okay, this formula can be used to find any term in the sequence. So let's highlight this. This is our formula that we're going to use to find any term in an arithmetic sequence, where n is the number of the terms, how many terms there are, and d is the common difference, which is what we were just talking about. The sum of all the terms in a finite sequence is found by, okay, so we have another formula that we need to know, is we have to know how to find the sum of all the terms in an arithmetic sequence. So those are the two formulas we're going to be dealing with today. Okay, so let's look at the first example. The first example says we're going to add all the integers from 1 to 100. So if we add all the integers, that means we want a sum, right? So we want the sum of the first 100 integers. The sum of the first 100 integers is, let's see, how many numbers are there? That's n, 100 divided by 2. And then the first term is 1, and the last term is 100. So this is the formula we use to find the sum of an arithmetic sequence. The first integers, 1, 2, 3, 4. There's a common difference there of 1, isn't there? So it would be 50 times 101. 50 times 101 is 5,050. That's the sum. Okay, write the first four terms of an arithmetic sequence whose first term is negative 14, first term negative 14, so that's my a sub 1, and whose common difference is 10. So the difference is 10, that's my d in my formula. Okay, so this is an easy one because I give you the first term and I tell you what the difference is. So we can simply add. We can just simply add 10 each time. So if we add 10, we get negative 4. Negative 4 plus 10 is 6, and 6 plus 10 is 16. Okay, so we don't really need that formula there, but we're going to use it in just a bit. Let's look at the next example. Find the 25th term of an arithmetic sequence, whose first term is 12, and whose common difference is negative 6. Okay, so we're going to use this formula. The first term is 12, so that's a sub 1. The common difference is negative 6, so there's my d. So we're going to find the 25th term. So that's n. My n is 25 in this case. So a sub 25 is the first term, which is 12, plus 25 minus 1, that's the n minus 1, times the difference, which is negative 6. So it's going to be 12 plus 24 times negative 6, which is negative 132. So the 25th term is negative 132. Okay, so we're going to write the 10th term. So I'm giving you a sequence. We're going to write the 10th term. So we want a sub 10. Okay, so I know what the first term is. So it's the first term plus n minus 1 times the difference. So n is 10 in this case. And then the difference is, well, we could get the difference by looking at the pattern, can't we? It looks like 5 to 8 to 11. It looks like the difference is positive 3. So we get 5 times plus 27, which is 32. Let's do it one more time. We're going to find the 25th term. The 25th term would be a sub 25. So it'd be the first term, which is 9. First term is 9, plus 25 minus 1 times the difference. So let's look at the pattern. The difference is goes down 4 each time. So my difference is negative 4. So make sure you put a negative if it's going down. So the 25th term is negative 87. Okay, so that's not too bad. All right, let's see. Insert 3 arithmetic means between 2 and negative 4. Okay, so insert 3 arithmetic means. So that means we've got between 2 and negative 4. So that means we've got 3 terms between 2 and negative 4 that we want to insert. So first let's draw the sequence here. Then we're going to use our formula. So let's see. A sub 1 is 2. A sub 5 is negative 4. We know what a sub 5 is. And we know what n is because we know how many terms there are. If we know the first and we know the last and there's 3 in between, that means that there are 5 terms in the sequence. So we have to find the difference. That's what we have to find. So we're going to use the formula. So we're going to say a sub 5, which is negative 4, is equal to a sub 1 plus n minus 1 times the difference. So we know everything except the difference. So let's see. We're going to solve for d. So I'm going to subtract 2, and that's 4d. So the difference is negative 3 over 2. So I'm going to subtract 1.5 each time. So 1/2, negative 1, and negative 5 over 2. All right, let's look at the next example. Write the first 5 terms of an arithmetic sequence in which a sub 17 is negative 40 and a sub 28 is negative 73. So let's see. I think we need to set up a system here because they give me 2 different situations. So let's make a note. We need a system here. So they give me a sub 17. So a sub 17 is equal to, let's see, the first term. I don't know the first term. I do not know the first term. So I'm going to put a sub 1 plus, I know that the n because they gave me a sub 17. So that's 17 minus 1, and I don't know the difference. But then they also gave me negative 73 is the 28th term. So a sub 28, which is negative 73, is equal to, once again, I don't know the first term, plus, that's the 28th term, so it's 28 minus 1 times d. So I have a system I need to set up. So let's see. I can do negative 40 equals a sub 1 plus 16d, and negative 73 equals a sub 1 plus 27d. So I'm going to do substitution, or I can do elimination, and I end up with a sub 1 is equal to 8, and d sub 1 is equal to negative 3. So the first 5 terms are 8. First term is 8, and the difference is negative 3. So it's going to be 8, then 5, then 2, then negative 1, and then negative 4. And then we can find the sum, which is subtracting 3, because that's the difference. And then I can find the sum of all the terms. The sum is, let's go back to our formula for the sum. The sum of n terms is n over 2 times a plus 1 plus a sub n. That's the formula we're going to use. So the sum of the first 5 terms is 5 over 2 times the first term plus the 5th term, which is negative 4. So it'd be 5 over 2 times 4, which is 10. The sum of the first 5 terms is 10. Okay, moving right along. All right, so write the first 4 terms of the arithmetic sequence, whose 11th term is 42 and whose 16th term is 57. So let's see. I think we're going to need another system. This example is exactly like the one we just did. It says do that again. Do you see that? So we're going to skip that, and you can do that one on your own, and then find the sum. So this example is exactly like this example we just did, where I give you 2 of the terms, and then you use a system to find what you need to know. Okay, let's look at this example now. Find the 10th term of an arithmetic sequence in which the first term is 3x plus y, 3x plus 2y, and the 6th term is 8x plus 12y. So we're going to write an equation that represents the nth term and find the sum of those 10th terms. Okay, so now we're going to use a sub 1 and a sub 6 to find the difference. A sub 1 and a sub 6. So the difference is x plus 2y, because a sub 1 is 3x plus 2y, and a sub 6 is 8x plus 12y.